Welcome back to the deep dive. Today, we are striking in for something pretty fascinating. We're looking at a really ambitious project in the OS world.
Yeah, a big one.
System 76's cosmic desktop environment, they're rebuilding it completely from the ground up for Pop OS.
Oh.
Well, it's more than just an update, isn't it?
Oh, absolutely. It's a major statement. And it sits right at this interesting crossroads, between users wanting these super efficient, customized ways of working
Right.
and this huge push industry-wide for much better software security. It's definitely a strategic move.
And the core of that strategy, the really surprising part maybe, is the language they picked. Rust.
Mm-hmm.
I mean, this isn't just some developer preference. We're talking about a shift towards memory-safe languages that's getting attention, well, way up high. Our sources point to the U.S. White House even.
That's right. There was that report back in February 2024, back to the building blocks, something like that.
Yeah, that's the one.
And it was pretty direct. It basically recommended developers start moving to languages like Rust, specifically to cut down on security holes that come from older languages. So System 76, choosing Rust. That lines up perfectly. It gives their decision some serious weight.
Okay, so that's our mission for this deep dive. Let's unpack why. Why ditch something established like GNU, something powerful, to build your own desktop in Rust? Especially when Rust, well, it's popular, but maybe still a bit young for huge GI projects like this.
Right.
And maybe more importantly for the listener, what's in it for you? What unique features does this new Cosmic actually offer that makes this whole massive effort worth talking about?
Let's start with the why.
Yeah.
Because, it wasn't just a technical thing. There was a strategic, almost political angle to it.
Okay. So before this new Cosmic, they had, well, they called it Cosmic 2, right? But it was built on GNOME.
Exactly. It was basically a sophisticated set of extensions layered on top of the standard GNU desktop.
That sounds like, the easier path. Why didn't that work out long term?
Well, it just wasn't sustainable. Think about it. You're building your custom house, but on someone else's foundation. GNOME is the upstream, and they have their own plans, their own release schedule.
Ah, okay.
So System 76 found that their customizations, the things that made Pop OS unique, like their app menu and dock, they kept breaking. Every time GNOME pushed a major update, things would just stop working.
Ouch. So they were spending all their time just fixing things, playing defense, basically.
Precisely. Just patching things up, reacting to changes they couldn't control, stuck in a maintenance loop, really.
Right. Limited by someone else's schedule.
So the decision to rewrite Cosmic totally from scratch in Rust. That was about taking back control, full control over the whole stack, from the bottom up.
So they could innovate on their own terms.
Exactly. Build a cohesive, polished experience without worrying that the next upstream update would pull the rug out from under them.
That makes sense. And that brings us back to Rust. Let's dig into the security angle a bit more. The White House report wasn't kidding around. What's the actual technical benefit here compared to, say, C++ Mile?
It really boils down to memory safety. With older languages like C and C++ Maya, it's actually surprisingly easy to make mistakes that corrupt memory. Things like buffer overflows, using memory after it's been freed.
The classic bugs.
The classics, yeah. And they're not just annoying crashes. Our sources are saying something like, 70%? 70% of the really critical security bugs that giants like Microsoft and Google report, they come straight from these memory safety issues.
70%? Wow. That's a huge number.
It's staggering, isn't it? And that's where Rust comes in. Memory safety in Rust means the language itself helps ensure your pointers are always valid.
How does it do that?
Through something called the borrow checker. And the crucial thing is, this happens during compilation, before the code even gets built.
So the compiler itself catches these errors.
Yeah, if your code has these kinds of memory safety problems, it just won't compile. It won't let you ship it. You essentially eliminate a whole class of vulnerabilities before they ever reach a user.
Okay, that sounds fantastic for stability, but
Yeah.
Hang on. If Rust is that strict, does it slow down development? Are they trading speed of coding for safety? And what about performance? Does it run slower?
That's a fair question. There is a steeper learning curve with Rust initially. That borrow checker takes some getting used to.
Right.
But the argument is, once developers are over that hump, they save so much time not having to debug those really tricky intermittent memory bugs later on.
Ah, okay. Pay a bit up front to save a lot later.
Kinda, yeah. And critically, Rust is fast. Performance-wise, it competes directly with C++ GAY. You get that low-level control needed for something like a desktop environment where every millisecond counts, but without the same safety risks.
So control, safety, and performance. Sounds like they found the sweet spot. Okay, that covers the strategic why. Now, let's shift gears to the what. What's the actual experience like for someone using this new Cosmic? What's the killer feature?
I think a killer feature is really about synthesis. Cosmic tries to blend the best of two worlds.
Which worlds?
The familiar, user-friendly graphical desktops, like GNOME or KDE Plasma that most people know, and merging that with the raw efficiency you get from keyboard-focused tiling window managers.
Ah, tiling managers like i3 or Sway?
Exactly.
Like those.
Okay, for anyone listening who hasn't used one, tiling managers are, well, they're power tools. They automatically arrange your windows, no overlaps, usually controlled entirely with keyboard shortcuts. Super efficient, but
But they often have a really steep learning curve, right?
oh yeah. You're usually editing complicated text files, memorizing tons of key combinations. It can be intimidating.
And that's the friction Cosmic aims to remove. The core idea is this integrated hybrid window management. Auto tiling isn't some add-on, it's built in, a first-class citizen. Okay, now that sounds interesting for everyday users. How does Cosmic make tiling less scary, more accessible?
It basically democratizes it. You get the efficiency windows snapping into place, less need for the mouse, using screen space better, but you control it all graphically.
So, no config files.
No scary config files. You can literally just click a button to turn auto tiling on or off. You can even set rules, like maybe you want your web browser to always float freely, but you want all your terminals to automatically tile. You set that up in the regular settings panel.
Okay, so if I've always been curious about that super organized, tiled workflow, but the setup seemed like too much hassle, Cosmic lets me try it out. Or switch between tiled and floating just using the normal settings.
Precisely. It's native, it's stable. And that integrated approach goes for the whole desktop shell, too. The top panel, the dock at the bottom, all configured right there in the system settings.
Which avoids that problem we talked about earlier, right? Where extensions break after an update.
Exactly. Customization is built in, so it should be much more stable and reliable long-term.
And I assume the speed and responsiveness of all this ties back to Rust and the tools they built. This is where the technical foundation matters, isn't it? They didn't just use existing GUI stuff.
No, they didn't. And this is a really key point. All the native Cosmic apps, the launcher, the terminal, the text editor, the file manager, they're all built using something called the Iced toolkit.
Iced. Okay, what is that?
It's a relatively young Rust native GUI framework, and it's declarative.
Declarative framework. Okay, what does that mean in practice? For me, the user.
Think of it like this. Instead of telling the computer step by step how to draw everything and how to change it when something happens that's imperative,
Right.
you just declare what the interface should look like based on the current
Right.
state. You describe the what, not the how. The Iced framework then figures out the most efficient way to update the screen to match that state. And importantly, Iced uses the GPU for rendering. So that declarative approach plus GPU acceleration means the whole interface should feel really smooth, very responsive. Animations, window resizing, all that stuff should just feel fast.
But that sounds like a huge risk, building their own toolkit. Why not use something already out there for Rust GUIs? Wouldn't that have been easier?
Easier, maybe, but it comes back to control and cohesion. They likely felt the existing options either weren't purely Rust native, maybe they relied on bindings to older C++ libraries like GTK or Qt.
Bringing back the dependencies they wanted to escape.
Exactly. Or maybe the existing pure Rust options just weren't flexible enough for the really custom integrated desktop experience System 76 was aiming for. Betting on Iced gives them total control, but yeah, it's a big technological gamble.
Because building a desktop is hard enough. Building the GUI toolkit for the desktop, that's like another level of difficulty entirely.
It absolutely is.
Yeah.
The future of Cosmic is completely tied to the future of Iced. If Iced doesn't mature quickly, if it doesn't get all the features needed for a modern desktop, Cosmic could stall.
What kind of features are we talking about?
Well, a really rich set of widgets.
Yeah.
You know, all the buttons, sliders, lists, and things application developers expect. Really solid accessibility features which are crucial and, maybe most importantly, attracting other developers to actually use Iced.
Right, you need an ecosystem.
You definitely do. So that's the trade-off. They took on the massive job of building the foundation themselves, hoping the payoff in autonomy and performance is worth it.
Okay, that paints a clear picture of the stakes. So let's look ahead. How does a brand new desktop like Cosmic actually plan to compete? GNOME, KDE, Plasma. They've got decades of development behind them.
Yeah, it's not going to compete head-to-head on feature count, at least not right away. The initial rollout is as the default for Puck OS.
So a niche play first.
Definitely a niche strategy. Its success hinges on appealing to a very specific group of users. People who crave that tiling efficiency, the keyboard focus, minimizing mouse use, optimizing screen space.
Power users, developers, maybe?
Those kinds of users, yeah. But crucially, users who want that efficiency without the traditional pain points. They want it polished, accessible, and easy to configure graphically.
So if you spend all day in front of your computer and wish it felt more like a streamlined cockpit, but you don't want to mess with config files, Cosmic is basically saying, we've got you.
That's the promise, the best of both worlds, without the usual headaches.
But what about apps? Developers mostly target GTK or Qt, right? Is it hard to get apps running on this new ICE-based system, or for developers to switch?
That's the other big hurdle, getting application developers on board. They need really compelling reasons to learn a new toolkit and support what's initially a much smaller platform.
How do they convince them?
The hope is that the performance, the stability, the potential security benefits of the Rust and ICE combination will be attractive, especially to developers perhaps frustrated with the complexities or limitations of the older toolkits. If Cosmic demonstrates it's genuinely more stable, more secure, faster, that could create some pull.
So if this whole thing works out, Cosmic isn't just another Linux desktop. It could actually validate this whole hybrid tiling model.
Exactly.
And maybe more significantly, prove that Rust is ready for prime-time, large-scale GUI development. That could open floodgates.
Absolutely. And the sources do mention Cosmic is designed with portability in mind. It's built for Linux first, obviously. But because it's Rust native with ICE, there's nothing fundamentally stopping it from being adapted to other Unix-like systems. Think FreeBSD, maybe even Mac OS down the line.
Interesting.
It's kind of a vision for how maybe operating systems should be built going forward.
Yeah.
Secure and stable right from the core.
Wow, okay. That was a fantastic deep dive. So let's recap the core takeaways. System 76 made this really big strategic bet on Rust, primarily for control to escape that upstream dependency trap and for the memory safety benefits.
Right, the stability foundation.
And that foundation let them innovate with this hybrid workflow idea, trying to blend the ease of graphical desktops with the power of tiling, but making it accessible through graphical settings. The goal is to give you, the user, a computing experience that's just fundamentally more stable and secure by design.
And that foundation is key, building out those memory safety issues at the language level. That offers something the established players, still tied to C++ OGG, find really hard to match. A truly dependable, really optimized digital workspace.
Which leaves us with one last pretty provocative thought for you to chew on. If System 76 actually pulls this off, if they prove that a new desktop built on memory safety with ICE, built with this integrated control, if it turns out to be significantly more stable, more secure than desktops built on legacy C++ code, will that create kind of irresistible pressure? Could it force everyone, the big Linux players, maybe even Microsoft, maybe even Apple, to seriously reconsider C and C++ for their core desktop interfaces, to maybe adopt memory-safe languages like Rust instead? Now, that would be a massive shift, potentially triggered by this one ambitious project, something to think about.